All right, today we did a quick introduction to forces on objects. And what we're focusing on here is, that's supposed to be objects, is for an arbitrary solid object sitting in a fluid, where you have the fluid approaching that velocity with a uniform velocity v0, approaching that object with velocity v0. Then the flow has a stagnation on the leading edge, maybe a stagnation on the trailing edge. The streamlines move around, as we've talked about for a potential flow. But along the way, there's forces that the fluid's exerting on the object and vice versa. And so what we want to think about here is how the pressure forces, say high pressure on the leading edge and low pressure on the trailing edge, so that change in pressure between the front and the back leads to a net force. And then in blue, I'll note the fact that we have shear forces acting along the surface of our object as the flow goes by. So the tau times A leads to a net force. And so together, pressure plus shear stress creates a drag force in the direction of flow, where here I'm writing it as the x direction. I should set up a coordinate system up here, say the x, z coordinate system. So the drag force is just equal to the x components of each of these two forces. The x component of the drag of the pressure and shear forces, which involves integrating over the surface p dA and tau dA. This is the integral of p dA, tau dA, with the appropriate taking the x component as you integrate. I'm not going to put the whole equation down here, but it's just taking the x component of each of those two components of the force. Finally, then the lift force F sub L is equal to the z component and the y component into and out of the screen. But here we're just going to focus on two-dimensional flow, so it's the x and the z components. So the lift force, F sub L, is just the z component. The drag force is in the flow direction, or in this case in the x direction. The next few lectures we're going to get into some more detail, focusing first on the shear stresses that are created by the boundary layer, and then talking about the pressure differences.